Hello students, this is the solutions video to your first extra exam problem. Again, this problem was not mandatory, but I will go through the solutions for those of you who wanted to practice for the AP exam. So let's get started. So let's take a look at what we got going on here. We've got a chart for g of x, we've got a graph for h, and then they tell us that f is the function to cosine 2x plus e to the sine x. So let's see what else they say. That g is a differentiable function. That's good. If it's differentiable, that means it's also continuous. All right, and the table gives us g and g prime at specific values. And then lastly, h is our little graph here. One of the things I'm noticing already about the little graph is we do have these corners, which means h is not differentiable everywhere, but everywhere except for those corners, h will be differentiable. So let's go ahead and let's take a look at the questions that they give us. So for question A, find the slope of the line tangent to the graph of f at x equals pi. So the slope of the tangent line, we know that that's just a fancy way of asking for the derivative. So I want f prime of pi. Well, if f of x equals cosine 2x plus e to the sine x, we take the derivative. Remember, the derivative of cosine, so f prime, the derivative of cosine is negative sine, leave the insides alone, times the derivative of the insides. And for the e sine of x, if you remember your exponentials, we take e to the exponent and leave it alone, and then we take the derivative of our exponent. So the derivative of sine is cosine. So now we have a nice formula for f prime of x. So f prime of x equals negative 2 sine of 2x plus cosine x e to the sine x. And now I just plug in pi. So it's negative 2 sine of 2 pi plus cosine of pi e to the sine of pi. So let's simplify this. If you remember your unit circle, this will become negative 2 sine of 2 pi is 0. If you don't remember your unit circle, you can always put them in calculators. Just make sure you remember your degrees and your modes. And then cosine of pi is negative 1. E to the sine of pi is 0. So I'll give you 0 plus negative 1. Anything to the 0 is 1, and you'll just get negative 1. And that's our final answer. So we can see that f prime of pi equals negative 1. If you were to put that down for your AP question, that would be a good answer. I'm going to leave this up here for a couple seconds so you can pause it to look it over, but then I'm going to erase everything and then start the next question. So pause it here to look it over. Alright, let's get started on question B. Question B asks me to let k be the function defined as h of f of x, and they want me to find k prime of pi. So we're looking for k prime. So let's start with k of x, just like before. We'll start with our function, and then try to find the derivative. So if k of x equals h of f of x, this right here, because we're doing two parts, this is going to be our chain rule. So I'm going to take the derivative of the outside, h prime, leave the insides alone, times the derivative of the insides. And that's it. That's my k prime. So now they want k prime at pi. So we're just going to plug in pi to all of our values. Well, f of x was this here. So k prime of pi equals h of f of, nope, not f pi, cosine 2 pi plus e to the sine of pi times f prime of pi. Now I'm not going to do anything with this because that should look really familiar. The AP exam has this great tendency to make you use your previous information in your next question to save you time. So we actually solved this 1 minute ago, and we know that this is equal to -1. So now we can just bring that out front. So we'll have that k, nope, I want blue. We'll have k prime of pi is equal to, we'll bring that -1 up front, times h, and we're going to go ahead and solve this out. Cosine of 2 pi equals 0, and then sine of pi is also 0, but that's e to the 0, so that's going to be +1. If you have any questions on these, I know I'm moving a little bit fast, but I want these videos to be concise. So if you have any questions, please talk to me in the live chats on Mondays and Wednesdays. So that means we want negative h of 1. So now we go over to our graph, and we look for h prime of 1. So what I'm going to do is I'm going to go over to 1, so we have negative, and go over to 1 here, and we want to find the slope of that point here. So we can see the line is going down 1 and over 3. So it has a negative slope, vertical component of 1, a horizontal component of 3. So it's negative -1/3. And this will give us a k prime of pi equals +1/3. Just as before, this is a great opportunity for you to pause and look it over, because in a moment I'm going to clear the screen and we're going to go over question C. Thank you. Alright, I may have just changed alignment a little bit, but that's because I moved the screen a little. I don't know if it's in the exact spot. But let's keep going. Problem C. Let m be the function defined by m of x equals g of -2x times h of x. Find m prime of 2. Alright, so a couple of big things you should see here. Right off the bat, you should be thinking, oh no, we have this multiplication here, so we're going to have to use the product rule. Which, if you don't remember, the derivative of u times v is u prime v plus u v prime. So that's going to be, so if m of x equals g -2x times h of x, then m prime, we're going to find the derivative of g of 2x. So that's going to be g prime of -2x times the derivative. This is a chain rule and a product rule. So the derivative of the inside times h of x plus, leave our g prime alone, leave our g alone, and then h prime of x. And there's nothing going on with our h prime, so we can just leave it like that. And then they ask me for m prime of 2. So that's going to be g prime of -2 times 2 times -2 times h of 2 plus g of -2 times 2 times h prime of 2. That's a lot of crazy stuff going on there, so make sure you're watching your signs, alright? And make sure you realize that this 2 is being multiplied, but these 2's are inside of my g of prime. So that's going to be -2 g prime of -4 h of 2 plus g of -4 h prime of 2. Now these parts are all going to come from up here, so we don't have to do any plugging in with the sines and the cosines. That's going to save us some grief. So then this will equal -2 g prime of -4 is -1. Just h, not h prime. H of 2. I don't like that. But that's actually going to be -2/3. You can tell because we're going 1 to 3 over 3 segments. G of -4 is 5. And h prime of 2, it's actually in the same line segment as before, so it's going to have the same slope of negative 1/3. Remember I said they'd like to have you keep using the same information? That's what they're doing here. So we can work out this math. That's 2 times 1 times 2. That's 4. There's 3 negatives, so it's going to be negative, and my denominator is going to stay the same. And then this is going to be negative 5/3. This is going to give me negative 9 over 3, which is going to give me negative 3. And again, this is a good answer for your AP test. Once again, I'm going to leave it here for a few seconds. You can pause it, look it over, and then I'm going to clear the screen and we're going to do part D, the last section. Excuse me. So question D. Is there a number C in the closed interval from negative 5 to negative 3 such that G prime of C equals negative 4? Justify your answer. Now there's a few different ways you could justify your answer here. I'm going to show you one. If you do it a different way and you're wondering if yours is legitimate, talk to me on the live chats on Monday or Wednesday. Let's get started. Is there a number C on the closed interval of negative 5, negative 3 says that G prime of C equals negative 4? Justify your answer. So remember, we're talking about G and only G. So let's look for any clues we know about function G and in these two parts. Well, remember we found that an extremely important part, that if G is differentiable, it's also continuous. So then we can see that we have that G, so let's take a look at G of negative 5 and G of negative 3 equals 10. And G of negative 3 equals 2. So to find the slope, or the derivative, we would do 10 minus 2 over negative 5 minus negative 3. And that would give you 8 over negative 2, which is negative 4. So by the mean value theorem, there exists a point on G between negative 5 and negative 3 with derivative equal to negative 4. And that would be a good answer on the AP exam. That would get you full credit. Again, there's a few different ways you could justify. If you want me to check yours, talk to me in the live chat. I'd love to see the different ways you approach this problem. Once again, I'm going to leave this up here for a few seconds for you to pause it. But really, this is the end of this video. So the next video will be solutions to question 2. Thank you, students.